and good morning. Hope you are well. Today we are going to continue our lesson 7, and we will cover pages between 181 to 187. The first topic is factors affecting the rate of reaction. Today we are going to focus on rates of reaction. We are going to see how we can improve the speed of a reaction, a chemical reaction. So there are a few reasons that um, a chemical reaction can be fast. So first is surface area of solid reactants. If we have a reactants which are solid, so surface area of the reactants is very important to be considered for a fast reaction. So I will talk about this with more details. The concentration of reactants, if it's liquid, so we need to look at the concentration. So the temperature is another factor, catalyst, and also in some reactions, light can be helpful. So today we are going to focus on the first three: surface area, concentration, and temperature. All right, the first one is surface area of solid reactants. If we have a solid reactants like calcium carbonate, so calcium carbonate can react with hydrochloric acid. This is the original the reaction. So the product will be calcium chloride and water and carbon dioxide. Through this equipment, we can explore the reactions. We can explore that how surface area can be important for a fast reaction. So we can compare two different solids of calcium carbonate. One sample, for example, like marble chips, can be sample B with a smaller piece. We can use a small piece of the calcium carbonate, and another one we can use sample A, which is larger, for example. Okay, so the experiment is carried out twice, two times. Once with sample A, which is larger than B. Okay, another one is sample B. So we need to do this experiment two times. In every condition should be same, like the temperature of the room or the weight of our samples and the amount of hydrochloric acid, and everything should be same, only the pieces of calcium carbonate. Sample A should be smaller, should be larger, and B should be smaller piece. All right, when they react, when carbonate reacts with hydrochloric acid, then carbon dioxide will be released from the reaction, the place. That's why we need to put a cotton wool to get the carbon dioxide. All right. So then we will receive these results. So based on the chart here, which is about loose in a mass based on the gram at the left, and the bottom is based on the time. While the time is passing, for example, this is based on the minutes, 1 minute, 2 minutes, 3 minutes, 4 minutes, we can see that the sample B can lose the mass quicker than sample A. For example, in point A, point 1, okay, at the minute 1, if we go up here and find the point for sample A is here lower than sample B, and B is here. That means B can lose the mass more than A. Then at the same point, if you check the left side, you can see the amount of the gram which sample B lost. It's at the, for example, minute 1, it's about 9, okay, about 0.9 gram, and for A it's about maybe 0.6, something like that, between 5 and 6. So at the earlier time, sample B lost their weight faster than more than A. That means B, which has a small chips, react faster. Okay, react faster and stronger with the chloride acid, with the uh, with the acid. All right, let me check here. There are totally 2 points that we can get from this experiment. First, the reaction is fastest at the start. For example, minute A or 2, something like that. This is shown the steepest of the curve, okay? The steepest of the curves over the first few minutes. Curve B is steeper than curve A. So that means curve B lost their mass, I mean smaller chips, sample B lost their mass faster or more than A. So this means that the gas CO2 is being produced faster with a smaller sample B. 2, the point 2, the total volume of the gas released in the same both experiment, but at the end they reach at the same point. That means both reaction lost same amount of the weight, or actually they produced same amount of carbon dioxide gas. They can make a complete reaction until the end, but the important part is the earlier time of the reaction. We need to see which one is faster, which reaction is stronger, and it has the high rate. So sample B showed that it was a faster reaction and stronger. It has a strong rate because small chips. Every condition were same as I mentioned. Only the pieces of the reactants were smaller. When you make a smaller piece of the reactants, like a bit powdery, not too much powdery, a bit powdery, that means you increase the surface area of the reactant. If you have any solid, you imagine you have for example, if you have a big piece of sugar, so that would be a smaller and a slower reaction if you want to mix in the water. Okay, same amount of water, same temperature, but if you have a smaller piece of a sugar, which is like a powdery, so you can mix with water faster, because when you reduce the size of the reactant, that means you increase the surface will be increased. So finally we can conclude that increasing surface area can improve the rate of reaction, make it quicker, but the time will be decreased. In in shorter time. In a shorter time, you can increase the rate of the reaction. So the second factor is concentration of reactants. That can be useful for solid, also can be used for liquid. So this experiment can be used by these apparatus here. You can see at the bottom right, and the acid in experiment C. Okay, here also we are going to use two different samples, and sample C has twice as concentrated as in experiment D. We are going to use magnesium to put in a hydrochloric acid. If we put a magnesium in hydrochloric acid, so there will be a reaction based on this reaction, magnesium and hydrochloric acid. Then we will get magnesium chloride and hydrogen gas. This hydrogen gas can be measured. Okay, can be measured how reaction is going on. Then for hydrochloric acid, we can use more hydrochloric acid in sample C, which has, we use less hydrochloric acid because it's a solution. So we are going to concentrate same amount of magnesium but half amount of hydrochloric acid, so the concentration of this solution for sample C will be twice higher than experiment D, the sample D. For the sample D we need to use more hydrochloric acid, so the concentration of the magnesium will be reduced to the half compared to the C. Okay, so here we have two different concentration of reactants. C, which is twice as concentrated as sample D. So the rest should be same. The temperature or anything, okay, should be same. Here is result. Based on the result and the graph you can see at the top right here, at the bottom of this graph we have time while the time is passing, and also the left side we have the volume of hydrogen, because here I said this reaction will lose the hydrogen gas, so we need to measure the hydrogen of the gas. So for the hydrogen gas, while the time is going on, the reaction will lose the hydrogen gas, amount of volume of the hydrogen gas. And we have sample C and sample D. As you can see, sample C has 1 mole per decimeter cubic decimeter acid, and here D is half concentration of C. The results show that the curve for experiment C is steeper than for D at the earlier of the time. For example, in 10 seconds or 20 seconds, 30 seconds, because this is based on the second. Okay, at the earlier of the time, C is steeper. That means C lost hydrogen gas more than C. So a reaction C using more concentrated acid is faster than D. The second one, for C start of twice is deeply as for D, okay, about twice. Yeah, if you check, for example, here, C, at the second C, you can see at the second C, sample D lost the amount of the gas volume about like 22 something, about 22, and C is about 45 something like that, 44. So you can see the loss of hydrogen is about 2 times, as we made a 2 times twice a concentration of the reactant. So this is same, but finally they will reach to the same uh, amount of losing volume of hydrogen. It's about 60. Okay, it's about 60 volume per cubic centimeter. Okay, they lose same amount. That means both reaction will be done at the same and complete. They make a complete reaction, but it depends on the concentration of the reactants, and whether the reaction can be fast at the earlier time, and another reaction would be slower. This can be used for some explosion, something like explosion, like bomb, TNT, something like that. They use same strategies of large surface area and concentration, and also temperature to make a exploding reaction. All right, at the end we have concluded that higher concentration can help for higher rate of reaction in shorter time. The third one is temperature. Another experiment uh, can be another experiment can be used this way. In this way, we can use sodium disulfate solution, and we need to put a paper with a cross, okay, cross drawn on the paper with like any color. So we need also put dilute acid on we need to have two samples, okay, two. One sample is with can be with like temperature, normal temperature, and another can be used by higher temperature. We need to give like heat, okay. For example, if we add a heat to one of the samples, then we need to check for the reaction, rate of reaction. This is the original the reaction. Okay, this is the reaction. Sodium disulfate with the hydrochloric acid, they react to each other, then they will produce sodium chloride, sulfuric dioxide, and water. So a reaction can be made to go faster or slowly by changing the temperature of the reactant. If we put, for example, a heat or any temperature, so the reaction will be faster, and they react to each other, and it will give you a not pure solution. It's a blue solution here, and another one here which is pure. They react slowly, so still you can see the cross line. So for this experiment you need to do it many times, then collect the data, then finally um, you can use the data to plot this graph. So you will get a plot something like this. At the bottom is temperature, and the left side is time for cross to disappear. So like you can check, for example, you can check the temperature. You need to measure the temperature like 25 or 23 Celsius. When you put the sample on the cross line, you need to measure the time, how long it takes to be disappear, the cross line disappear. Here there is one example, like in temperature 23 Celsius, your sample will be disappear about 130 seconds. The second temperature, like 28 temperature Celsius, 28 temperature Celsius will take until, for example, 95 second to be disappeared, that cross line to be disappeared. While you are increasing the temperature, so the time for disappearing of the cross line will be reduced. That means if you increase the temperature, that means if you increase the temperature here, so the time will be decreased. If you increase the temperature, time will be decreased. That means your reaction will be faster, quicker, and the two reactants react to each other strongly if you increase the temperature. So at the end we can conclude that increasing temperature will increase the rate of reaction in shorter time. Okay, the time will be quicker. All right, that's all for today. We have learned three factors can affect on rate of reaction, make it faster. So now you can look at the question number one for as your assignment. Please submit your answer. You can hear. Um, you can pause the video and screenshot the picture, the question, and then submit your answer. Also, keep in your mind that these experiments that through your books, through our lessons, uh, when we are studying on experiment, those are very important on your third paper of your IGCSE exam, your chemistry IGCSE exam, because the third paper is related to experiment. It gives you experiment and then ask you some question. Then you need to solve the questions. All right, that's all for today. Thank you so much. Take care.